Alright, so I'm just going to jump into section 3.2. It's a section on function notation. Function notation for a lot of students is confusing. It was absolutely confusing for me when I took my college algebra class. I actually took my college algebra, I actually took pre-calculus at GCC back way long ago, and I didn't really understand function notation, even though I was able to, kind of get decent scores on my tests. So the understanding of function notation, it's a slow process. I mean, if you understand it completely immediately, you're brilliant. But you should be able to at least understand how to do the problems well enough to get through the test. And the more you get exposed to function notation, the more you kind of see its beauty and its simplicity in some sense. So the first 18 problems in section 3.2 give me 4 functions that will work for each of the problems between 1 through 18, but these functions aren't constant. So the fact that I have k of x equal to the fraction 2 over x plus 3 for problems 1 through 18, if in problem 19 I introduce the k of x function again, it's probably not going to be 2 over x plus 3. So only for these specific 18 problems, these functions will be used. Each of the problems is really written in a really compact form that's just a letter followed by a parentheses, and there's either a number or a letter inside that parentheses. And what each of the questions between 1 and 18 want me to do is they want me to evaluate the function at that value for x. So problem 2 calls out the f function because of that f, and instead of having an x in the parentheses, it has a negative 2 in that parentheses. What it wants me to do is change the x in the f function to negative 2. Usually when I'm replacing a function x, or function's variable, with a number, I put that number in a parentheses. It's not always 100% necessary to do that, but it's never wrong to do that, and it's safe to do that. So I'm just going to rewrite this problem as 3 times negative 2 plus 4 by changing the x to negative 2, and then I'm just going to do order of operations. So I'm going to get f of negative 2, 3 times negative 2 is negative 6, and negative 6 plus 4 is negative 2. My answer to number 2 could be f of negative 2 equals to negative 2. Or if you want to, you can just write the number negative 2. And if you want to attach a letter to your answer that's not function notation, it should really be the letter y. The number inside the parentheses is the x value. Generally, when I'm plugging numbers into a function for x, the value that I get out, if I want to attach a letter to it other than the function notation, I attach a y. Problems 3 and 4 call out the g function. The g function's x squared plus 5x plus 6. The 0 is already put in for that x. I'm going to put a 0 in for those two x's and simplify. This I probably could write an answer to without even showing any work, because the pieces with zeros are going to zero out. So g of 0 is 0 squared, which is 0 times 0, which is 0, plus 5 times 0, which is 0, plus 6. In for my answer, I can write g of 0 equals to 6, or I can just write the number 6, or I can write y equal to 6. It would be wrong to write x equal to 6, because for this particular problem, x is equal to 0. So hopefully with that you can do 1 and 3. You might be able to do a lot more problems without watching me do all of 1 through 18, but you're probably going to hit a roadblock somewheres. I would suspect a lot of you, if you tried to go on, got stuck on number 5, which calls out the h function. You notice that the k, the f, and the g functions have x's written to the right of the equal sign, but the h function doesn't. The h function is called a constant function, which means regardless of what number's in the parentheses, it's going to simplify to 4. If you needed to, you can rewrite the h function or imagine the h function differently. To have an x to the right of the equal sign. I might write it as h of x equals 0x plus 4, because this is the same as h of x equals to 4, because 0x is 0 times x, which is 0 plus 4, which is 4. It's not necessary to reimagine the h function that way, but if I reimagined the h function that way, I can say for number 6, h of 3 is 0 times 3 plus 4, which is h of 3 equals 0 plus 4, and then my answer to number 6 is going to be h of 3 equals to 4. It's not necessary. When you have a constant function, the answer to that function evaluated at any number is going to be 4. If I did your problem 5, I could just say the answer is h of 2 equal to 4, or I could use my reimagined function and say this is 0 times 2 plus 4, so h of 2 equals 0 plus 4, and h of 2 equal to 4 for an answer. But immediately when I see a function that doesn't have a letter, I call that a constant function, and it's constantly, that's the y value that you get, it's always constantly the same number, so it's constantly going to be 4, and it's never ever going to give you a different y value. If there's no x to the right of the equal sign, there's no place to put the x, which means my answer can't have anything but that constant. For number 7 and 8, it's calling out the k function. So for 8, I'm going to plug in -6 for x. This is one of the only times that when I'm plugging a number in for a letter that I really don't need a parentheses. I'd call that like a naked x. If there's not a multiplication or an exponent associated with a variable, the parentheses then isn't necessary that I've been using for each of the other problems. But if I put that -6 inside a parentheses, it's not wrong, it's just not necessary. It would have been smarter had I realized that that parentheses doesn't serve any purpose because there isn't any multiplication or exponents associated with that x. So now I'm just going to simplify this. -6 plus 3 in the denominator is -3. So for an answer, I could write 2 over -3. This would be an okay answer. I definitely wouldn't change this to a decimal, because that's a repeating decimal and it doesn't terminate, and repeating decimals we almost never write as an answer. It probably looks odd, at least it looks odd to me, to see the negative in the denominator of that fraction, and it would be better if I moved that negative up to the numerator, or if I wrote that negative in front of my fraction for an answer. If I did this on my calculator, 2 over -6 plus 3, my calculator is going to turn it into a decimal first. If I did 2 divided by parentheses -6 plus 3, hit enter, it gives me a decimal, and then math, enter twice, gives me -2/3. It doesn't give me it gives me this, -2/3. Thinking about investing in the new version of the TI-84 calculator that just does better work with fractions. Thinking that eventually, as these videos get to be 2 or 3 years old, most students won't have the old version of these calculators that doesn't do fractions so nice. But for what it's worth, you can have just any version of these fractions, or you could have this kind of sideways fraction that my calculator writes. You can write a y equals, or you can just write the fraction itself. So there's lots of different ways to write this answer. Here's a bunch of different ways: writing the initial function next to the problem, writing next to the answer, writing y next to the answer, or just leaving the answer kind of naked. Alright, so you should be able to do 7. The next few problems are where students start to mess up. Not so much because the algebra is bad, it's because they try to do more. And for each of the problems between on this sheet anyways, inside the parentheses there's either a letter are a number plus or minus a letter. And when that happens, I'm going to do exactly the same thing that I did when I plugged a number in. What I won't do is set that, whatever that comes out to, equal to 0. So to do problem 10, to do f of c, I'm going to take the x in the function and change it to c. I put that c in a parentheses, but had I written that c without a parentheses, it would have the same meaning. This means 3 times c plus 4. Without the parentheses, it still means 3 times c plus 4. There aren't any like terms, so there's no algebra I could do here to write this better. I can't add these to get a 7c, because you can't add a term with a c to a term without a c. And the big thing that students want to do is they want to take this and set it equal to 0. That's actually wrong to do. It's not being asked for, and it's extra work. If it wanted you to set this equal to 0, it would have said solve f of c equal to 0. So if this was the problem, it would be correct to go 3c plus 4 equal to 0, minus 4 from both sides and get 3c equal to negative 4, divide by 3 and get c equal to negative 4/3. But that's not how the problem was written. I don't see it. I just said find f of c. Doesn't say set f of c equal to 0 and solve for c. Because the problem doesn't say find where f of c equal to 0, you need to stop right here. It would be absolutely wrong to set this equal to 0 and solve for x, because it's not asked for, or solve for c. And a lot of students on the test from this section will feel the urge to do this algebra because this feels like it's too simple of a problem. But this is completely the answer that we'd want, other than if you don't want to write the left-hand side, or if you want to write a y in place of the left-hand side. You can do that as well. So for each of the next 5 or 6 or maybe even 8 problems, I'm just going to plug what's in the parentheses into the x, into the original problem, and I'm going to do any algebra that I can in terms of simplifying, maybe clearing parentheses and combining like terms. The only algebra I did in number 10 is I cleared the parentheses. I didn't really clear it, I just dropped it. Alright, so for number 12, I'm going to change that x was already changed to a b minus 2. I'm going to change that x to a b minus 2 and get 3 times b minus 2 plus 4. That's going to give me f of b minus 2. I'm going to clear the parentheses by going 3 times b, which is 3b, 3 times minus 2, which is minus 6, and then plus 4. The minus 6 and plus 4 are like terms. They can be combined. Because they have opposite signs, I subtract and take the sign of the larger. And that's going to lead me to something that's suitable for an answer. I'm going to write f of b minus 2 equals, I'm going to combine those. It's going to be 3b minus 2. And again, if you don't write the problem next to the answer, it's okay if you just wrote 3b minus 2. And it would almost feel odd with the b in there, but if you wrote y equals 3b minus 2, it's not wrong. It just feels different when I have a b in the parentheses as opposed to an x in a parentheses. When I have an x in a parentheses, a real y feels like the right thing to write if I want to write something different than the function notation or just kind of the answer without any notation. All right. So 14 calls out the g function, and 13 calls out the g function. Because the g function is factorable, my answer is going to be factorable when I change the x to 3a. So let me do that, and let me factor it as well. So let me plug in 3a for each of the x's in the g function. So I'm going to get 3a squared plus 5 times 3a plus 6. The g function is the only function that has an exponent in it, so it's the only one that might 2 parentheses factor. And let me leave myself some room here. So I'm going to get g of 3a. 3a squared, I square the 3, and 3 squared is 9. I square the a and get a squared. 5 times 3a gives me 15a, and the plus 6 is a plus 6. There's a common factor of 3 that I could factor out. When I factor out a 3, I'm left with 3a squared plus 5a plus 2. Just because that does factor, I'm going to go ahead and factor it. So let me go ahead and factor 3a squared plus 5a plus 2. And I'm going to use bottoms up. So to use bottoms up, I'm going to multiply by 3 and rewrite. I'm going to multiply this 3 by that 2. I'm going to rewrite it so it doesn't have the 3 in front of the a squared, and the 2 is going to turn into a 6. Then I'm going to factor that. That's the second of my 3 steps of bottoms up. This factors into a plus 2 times a plus 3. And then the last step, I'm going to divide by 3, reduce, and bottoms up. So I'm going to divide that by 3, that by 3. First fraction doesn't reduce, so I bottoms up it and get 3a plus 2. Second fraction reduces, so I'm going to reduce it and get a plus 1. So for a better answer than that I have written right here, probably the best answer for number 14 would be g of 3a equals 3 times 3a plus 2 times a plus 1. More often than not, if there's a function that has a square in it, if the initial function factors, when you're plugging something into that function, a letter into that function, it'll still factor. Let me do problem 16 to do g of x plus 1. To do g of x plus 1, I'm going to change both of those x's to x plus 1. So I'm going to get x plus 1 squared plus 5 times x plus 1 plus 6. To do x plus 1 squared, it's foiling. You have to do x plus 1 times x plus 1. Firsts are going to be x times x, which is x squared. Outers are x times 1, which is plus 1x. Inners are 1 times x, which is plus 1x. Lasts are 1 times 1, which is plus 1. So that's doing the x plus 1 squared. Now I'm going to go 5 times x and 5 times 1 and get plus 5x plus 5. And bring down the 6. And now I'm going to combine like terms. This 1x, 1x, and 5x. I'm going to go 1 plus 1 is 2 plus 5 is 7. And for the numbers, 1 plus 5 plus 6 add up to 12. That's factorable. That's easy factoring. My best answer for problem 16 is going to have that factored. I'm going to write g of x plus 1 equals, and that factors into x plus 3 times x plus 4. I like the blue quite a bit, but as I look at it, it probably doesn't write as nicely as my black pen, so I'm going to pull back my black pen, even though I prefer writing with color. Alright, so your problems 13 and 14 should feel real similar when you get them, work on those. Last two problems in this grouping, 17 and 18, call it the k function. I'm going to plug in a minus 2 for the x, because the x was changed to a minus 2. I'm going to get 2 over, I'm going to write a minus 2 plus 3. The k function is the only one of these functions where you don't really need to substitute using a parentheses, but it's not wrong. But the parentheses, if I impose it when I'm doing the k function, can just be dropped, because this parentheses doesn't have multiplication in front of it or an exponent outside of it, so I can just drop this parentheses. In the denominator, I have these like terms that I can combine to a 1. And I'm going to be left with a fraction that doesn't reduce. I get 2 over a plus 1. And that's going to be the best answer for number 18. The next problems give us new functions, but just for f and g. It doesn't even introduce an h and a k. And they ask us to do operations with functions. They ask us to add, subtract, multiply, divide, and compose functions. I'm going to scribble up a little cheat sheet for me. Yeah, because I usually do this. So let me make a little cheat sheet that I'll refer to as I'm combining my functions together. So this notation f plus g of x is the same as this notation, f of x plus g of x. And what this asks me to do, these both ask me to add the right side of the f function plus the right side of the g function. And I'm going to sneak into your problem 19 just to give you an idea of when you might be asked this. So if I look at the problems between 19 and 27, each of the problems between 19 and 27 use for the f function 2x plus 3, and for the g function 2x squared plus 5x plus 3. Problem 19 asks me to find f plus g of x, and this really means to find f of x plus g of x. And in each of the problems between 19 and 27, once I understand what the problem's asking me to do, I'm going to change from function notation into non-function notation. The non-function notation for f of x is 2x plus 3. The function notation for g of x is non-function notation for g of x is 2x squared plus 5x plus 3. Always, when I'm substituting to go from function notation to non-function notation, it's okay to put your function inside a parentheses. When the operation is plus, neither parentheses is needed, but I'll just be safe and do that. So I changed from function notation that kind of had the functions together with 1x into function notation that had the functions separated with 2 x's, and this plus sign between them remained. And now I'm going to change from function notation to non-function notation. I'm going to change the f of x function to 2x plus 3 and the g of x function to 2x squared plus 5x plus 3. And now I'm just going to work this out. So I'm going to get f plus g of x equals to, and each parentheses that I imposed really wasn't necessary, and they can be dropped without any changing. If there was a minus sign in front of a parentheses, an exponent outside of a parentheses, or a multiplication in front of a parentheses, I'd have to do some work to, couldn't just drop the parentheses. I'd have to multiply or change signs or FOIL. Now I'm going to combine like terms and write this in a nice order. So I'm going to get f plus g of x. The 2x squared I'm going to write first. And then I'm going to add the 2x and the 5x to get a 7x. I'm going to add the 3 and the 3 to get 6. This I need to check if it factors, so I'm going to give it a shot at factoring this. So this might be an okay answer, but I might improve upon it. So I'm going to try to factor 2x squared plus 7x plus 6. First thing I'm going to do is multiply and rewrite. Actually, I'm going to multiply by 2 and rewrite. That's going to make this x squared plus 7x plus 12. Second step is going to be to factor. This factors into x plus 3 times x plus 4. And then I'm going to divide, reduce, and bottoms up. Started off multiplying by 2. I'm going to divide by 2. First fraction I'm going to bottoms up and get a 2x plus 3. Second fraction I'm going to reduce and get an x plus 2. The best answer to problem 19 would be f plus g of x, writing the initial question with the answer as 2x plus 3 times x plus 2. It absolutely would be okay if you just wrote 2x plus 3 times x plus 2 and didn't write the function notation. If this was a test question and you didn't catch the factoring, I might not take any points off and I might just write it factored down. Problem 20 wants me to find g minus f of x, and I flip back to this sheet. G minus f of x is going to ask me to do g of x, which was the letter written first, then the minus sign, and then f of x. It says g of x minus f of x. This asks me to subtract the right side of the f and the g and the f function. The original notation and the rewrite notation both ask me to subtract the right side of the functions in that specific order. Let's try to squeeze it on this paper. So g minus f of x equals g of x minus f of x. And then I'm going to put parentheses minus parentheses. In the first parentheses, I'm going to put the right side of the g function, which is 2x squared plus 5x plus 3. In the right side of the second parentheses, I'm going to put f of x, which is 2x plus 3. I just don't have room to write it nicely. I should be writing g minus f of x equals, and then for this, I'm just going to drop that parentheses and get 2x squared plus 5x plus 3. Minus sign, the minus is going to attach to the 2x and flip the sign on the 3. It gives me minus 2x minus 3. And then I'm going to combine like terms. The 5x minus 2x are going to combine to be a 3x. The 3's are going to cancel. I'm going to get g minus f of x. The 2x squared is going to hang out. The 5x minus 2x is a plus 3x. And then the 3's cancel. There's a common factor of an x that I should factor out. I missed the blip, so I wrote g and break. The g and f of x each got in a parentheses. I should be writing the problem next to my answer as I do the work. The g parentheses I just dropped without any changing. The f parentheses, the minus attached to the 2x and flip the sign on the 3. That's why that 3 went negative. I combined like terms. 5x minus 2x gave me a 3x. The 3's canceled. And when I go to write my answer, if my answer is factorable, I should factor it. I'm going to factor out a common factor of an x. I don't need to write the original problem next to my answer, but I usually do. And that's what you get when you factor out that common factor of an x. The next two operations that we're going to have, so we have addition, subtraction, and we're going to have division and multiplication. This f divided by g of x, written like this, wants me to form a fraction with the right-hand side of f in the numerator and the right-hand side of g in the denominator. The fractions in some sense are the nicest because they're the ones that reduce the least. So I need to form a fraction with the right sides of f of x in the numerator and the right side of g in the denominator. The big thing here is the only way this can reduce in terms of algebra is if you can factor and cancel. So the only possible way to simplify this is to factor and cancel. There aren't going to be any like terms that I could reduce, and you won't be able to cancel if it doesn't factor. So I'm going to sneak off and do your problem 21. Your problem 21 asks me to do f divided by g of x, and f divided by g of x wants me to do f of x over g of x, and that's going to give me f divided by g of x is a fraction with the right side of f in the numerator and the right side of g in the denominator. I never use parentheses when I'm doing division. They're absolutely not necessary. So I can't cancel the 3's. I can't cancel the 2x with the 2x squared. You can only cancel fractions like that if there was straight multiplication. If the numerator was like 2x times 3 over 2x squared times 5x times 3, then you could cancel the 3's. I could actually cancel these x's and I could cancel those 2's. But once there's pluses or minuses between numbers and letters, you can't cancel. The only way you can cancel a fraction when there's adding or subtracting in the numerator is if you can factor and cancel. So let me attempt to do that. So I'm going to try off to the side here. I'm going to try to factor 2x squared plus 5x plus 3 by bottoms up. So I'm going to multiply and rewrite to get x squared plus 5x plus 6. I'm going to factor this and get x plus 2 times x plus 3. And then I'm going to divide, reduce, and bottoms up. Start off multiplying by 2. I'm going to end up dividing by 2. First fraction is going to turn into x plus 1. Second fraction, I flip it up and get 2x plus 3. So I can rewrite the denominator. So this is going to be f divided by g of x equals to 2x plus 3 over x plus 1 times 2x plus 3. This is reducible. These 2x plus 3's can now cancel. I can't write just x plus 1 for an answer. When I go to write my answer to problem 22, I have to leave a 1 behind in the numerator. You can't write a fraction without a numerator. If you cancel the entire numerator, you leave a 1 behind. So I'm going to get 1 over what's left in the denominator, x plus 1. And because I canceled out the factoring in the denominator, I don't need the parentheses around the x plus 1. All right, you can't cancel those 1's. And the next thing we have is multiplication. And multiplication is like the only one that we do that if we choose to multiply out something that starts factored, that we don't factor it back. So this right there, that means times. And to do g times, with a closed circle, f of x, that's the same, for what it's worth, that's the same as gf of x without a symbol between. So a closed dot between means times. It would also be the same if I wrote g times f of x. All of these mean to take the right side of the g function and multiply it by the right side of the f function. And usually we clear the parentheses and don't refactor. This is the only one of the operations that we're going to do between adding, subtracting, multiplying, and dividing that we won't factor. The reason being is on the first step it's already factored, and if you factor, you just get back to the first step. So I'm going to try to squeeze my problem 22 in here. So 22 wants me to do g times f of x. That closed circle means times, and g times f of x means g of x times f of x. And if I just write the letters g of x and f of x next to each other, that implies times. And I want to multiply the right side of each function together. So g times f of x is going to be g of x, which is 2x squared plus 5x plus 3, times f of x. I don't have room on this sheet, so let me pull out another sheet here. So g times f of x equals g of x times f of x. So g times f of x equals g of x, 2x squared plus 5x plus 3, times f of x, 2x plus 3. That's factored. If I wanted a factored answer, I'd probably just leave it right there. But usually we want you to do a little bit of algebra, and this is nasty algebra. I'm going to clear these parentheses by doing 6 multiplications. I'm going to start off by going 2x squared times 2x. That's going to give me a 4x cubed. Then I'm going to do 2x squared times 3. That's going to give me a plus 6x squared. Then I'm going to do 5x times 2x. That's going to give me a plus 10x squared. Then I'm going to do 5x times 3. That's going to give me a plus 15x. Then I'll do 3 times 2x. That's going to give me a plus 6x. And then I'll do 3 times 3. That'll give me a plus 9. I'm just going to combine like terms. The 4x cubed I'm going to write first. The 6x squared and the 10x squared I'm going to add together and get 16x squared. The 5x, the 15x and the 6x I'm going to add together and get 21x, and I'm going to bring down the plus 9. That actually will factor, but I'm not going to factor it because it started off factored, and this is the only one. The multiplication we usually do not factor. the addition, subtraction, and division, we usually make a shot at factoring because the factoring might lead to some canceling. 23 is just another division, but it's an upside down division. 23 wants you to do g of x divided by f of x. And remember that this factors into 2x plus 3 times x plus 1. So when you're doing problem 23, you're going to factor that g of x, it's going to cancel, and your answer is not going to be a fraction because you're going to cancel out the entire denominator. Last operation. This open circle doesn't mean times. This open circle means composition of functions and not times. And so I should probably scribble up a sheet for it. So to do f composed with g of x, some people would just call that fog. F composed with g of x, I've been writing what these things equal to. Now I'm going to do that again. This means f of g of x. This means change each x in the right side of the f function first to g of x, and then replace the g of x with what it's equal to. This for students is monstrously confusing because it just doesn't feel natural. The adding, subtracting, and multiplying and dividing, in some sense they feel natural because you add, subtract, and multiply and divide with numbers, so it's not like a new operation. But composition of functions is something that's unique to functions that you don't do with numbers in general. And so f composed with g of x means f of g of x. So let me do problem 24 to kind of walk you through what I mean. So problem 24 starts off, it asks me to find f composed with g of x. And I say this is the same as f of g of x. And so what I'm going to do is go to the f function and change that x to g of x. So f composed with g of x equals 2 times g of x plus 3. That's all I did is change that x to a g of x. Just like when I found like f of 2, I would change that x to a 2. Or if I find f of 7, I change that x to a 7. To find f of g of x, I change that x to a g of x. But g of x isn't the best notation because I have something that's better than g of x that I can use. And that's kind of what I said. So I first change each x in the right side of the x function first to g of x. I took that x and I changed it to g of x. That's what I did first. Now I'm going to replace the g of x with what it's equal to. Well, what is g of x equal to? For this problem, 2x squared plus 5x plus 3. So I'm going to say f composed with g of x equals 2. And I'm going to replace the g of x function with 2x squared plus 5x plus 3. I'm going to leave this plus 3 here. That is f composed with g of x, just not simplified so nicely. So I'm going to clear the parentheses and combine like terms. So f composed with g of x, I'm going to go 2 times 2x squared, which is 4x squared, 2 times 5x, which is plus 10x, 2 times 3, which is plus 6. Bring down this plus 3. This gives me f composed with g of x equals to 4x squared plus 10x plus 9. I think that's the answer and that this is prime, but I'm going to try to factor this up on the top just to make sure I have an answer that's as best I can do. So let me try to factor 4x squared plus 10x plus 9. First step, I'm going to multiply and get x squared plus 10x plus 36. Now I need to factor this. If this doesn't factor, then the initial problem that I'm attempting to factor is prime. Here, my lasts have to multiply to 36 and add to 10. So I'm going to write all the factors of 36. 1 times 36 multiplied to 36, those don't add to 10. 2 times 18 multiplied to 36, those add to 20 and not 10. 3 times 12 multiplies to 36, those add to 15, which isn't 10. 4 times 9 multiplied to 36, those add to 13, which isn't 10. And 6 times 6 multiply to 36, but add to 12, that isn't 10. So my answer isn't factorable because when I get to the first stage and bottoms up where I need to factor, I get something that's prime. So this whole thing is prime. And my answer to problem 24 is just going to be that, probably that written a little more clearly without the scribble. So f composed with g of x equals 4x squared plus 10x plus 9. I'm going to do your problem 25 and then not my problem 26, and I'll let you do problem 27. Problem 25 wants me to do g composed with f of x, have the letters written in different order. This is going to equal to g of f of x. So what do I have to do? I have to go to the g function and replace each x with f of x. So I'm going to say g composed with f of x equals to 2 times f of x squared plus 5 times f of x plus 3. That's just taking that x and changing it to f of x. So that's what that notation tells me to do. G of anything asks me to replace that anything with what's in the parentheses. I took that x, changed them to f of x. And now I'm going to do g composed with f of x equals to 2. And now I'm going to replace the f of x with 2x plus 3. So times 2x plus 3 squared plus 5 times 2x plus 3 plus 3. Ugh. Now orders of operations get important. I should do exponents first. So g composed with f of x. The first thing I should do is 2x plus 3 squared. And 2x plus 3 squared means 2x plus 3 times 2x plus 3. That's a foiling. You do firsts are 2x times 2x, which is 4x squared. Outers are 2x times 3, which is plus 6x. Inners are 3 times 2x, which is plus 6x. Lasts are 3 times 3, which is 9. So that parentheses that I underlined, it comes out to be 4x squared, which are the firsts. The outers and inners add to 12x, and then plus 9. So I'm doing orders of operations, although I might be able to do more than that on one step. But when I see a line that needs to be simplified, if there's an exponent, I should do exponents first. Now I'm going to do the multiplication to clear the parentheses. So I'm going to get g composed with f of x equals to 8x squared, going 2 times 4x squared, plus 24x plus 18, and then plus 10x plus 15 plus 3. I'm going to combine like terms. I get g composed with f of x equals to 8x squared. I'm going to add the 24x and the 10x and get plus 34x. And then I'm going to combine the 18 and the 15 and the 3. That comes out to be 36. There's a common factor of a 2. I'm going to factor it out. And I think what's going to be left is going to be prime. And the numbers are a little bit big for me to want to try to factor them, so I'm just going to gamble and think that it's prime. If on a test, the composition comes out to have kind of really large numbers, just assume that it's prime. And if you really feel the urge to try to factor it, you can try to factor it. To try to factor this, I'd have to multiply 4 times 18 and get 72. Oh, it does factor. Heck, let me factor it since it factors. But I wouldn't expect this from you on a test. But I'm going to try to factor 4x squared plus 17x plus 18. First step is to multiply and rewrite. I'd get x squared plus 17x plus 4 times 18 is 72, I think. And then when I try to factor this, it's a double plus. It's a double plus. My last have to multiply to 72 and add to 17, and that's going to be 8 and 9, because 8 times 9 is 72, and 8 plus 9 is 17. Now I'm going to divide by 4. First fraction reduces to x plus 2. Second fraction, I bottom up and get 4x plus 9. So in terms of an answer, that should be replaced with the 4x squared plus 17x plus 18. The numbers are a little bit big. Usually, if you miss factoring on a test, I usually write it in, but don't ding you for it. If you're going on to calculus, your factoring skills need to be spectacular, and factoring skills, even with grungy problems, need to be spectacular, so you should probably, try to perfect your factoring. So I'm skipping 26, you should do 27. I'm going to do 28 through 36, and then I'll break this into a part 2 video. So 28 through 36 are exactly the same set of questions. I just changed the I really just changed the g of x, I think. I changed the f of x to something that's very similar to that g of x, but different. And I changed, so they're different functions, but the same kinds of questions. So for problem 28, I'm asked to find f plus g of x, and that equals f of x plus g of x. So f plus g of x will equal the right side of the f function, 2x squared minus 5x minus 3, plus the right side of the g function, x minus 3. Those parentheses absolutely weren't necessary. I'm just going to drop those and get 2x squared minus 5x minus 3 plus x, which is really 1x, minus 3. I'm going to combine the minus 5x and plus 1x and the minus 3 and minus 3 and get f plus g of x equals 2x squared minus 4x minus 6. I'm going to pull out that common factor of 2 and get 2 times x squared minus 2x minus 3, and that factors as well. The best answer for problem 28 is going to be f plus g of x equals to 2 times x plus 1 times x minus 3. The important thing is to know what to do on the first step. My first step, I split this into an f and the g separated by an addition, and then I replaced each of the f and g with the right sides inside of parentheses. In this case, I was able to drop both parentheses because there weren't any multiplications, exponents, or negative signs in front of the parentheses. I combined like terms, and then I factored. When you go to do g minus f of x, you're going to say this is g of x minus f of x. Then you're going to say it's x minus 3 minus 2x squared minus 5x minus 3. You're going to combine like terms. You're going to drop the parentheses. These signs are going to change. You're going to get a minus 2x squared, a plus 5x, and a plus 3. You're going to combine like terms, write it in a nice order, and try to factor a little bit. All right, so I'll do 30, which is the easier. When you do 31, this is the one where you're going to multiply it out, but you're not going to factor it. When I do 30, f divided by g of x equals a fraction that has f of x in the numerator and g of x in the denominator. So my f divided by g of x is going to equal 2x squared minus 5x minus 3 over x minus 3. I'm going to factor that. So to factor 2x squared minus 5x minus 3, first I multiply and rewrite and get x squared minus 5x minus 6. Then I factor that, factors into x plus 1 times x minus 6. Then I divide, reduce, and bottoms up and get 2x plus 1 times x minus 3. I was just going to write down what it factored into, but and so I really sped through it, assuming that you don't need me to teach you how to factor, that you already know how to factor. But just in case you're not up to speed on factoring, I did the factoring really super fast, thinking that most students would just not want to see that. Now I've got canceling that can be done, and if I cancel the entire denominator of a fraction, my answer doesn't have to be a fraction. It's just going to be what's left in the numerator, and what's left in the numerator doesn't need to go in a parentheses anymore because there's no factoring left in the numerator. So my answer is just going to be 2x plus 1. So you're 31, you're going to distribute and clear the parentheses, and 32 and 33 look different enough that me doing 32 is probably not going to help you do 33, so let me do 33. 33 wants me to find f composed with g of x, and that means to find f of g of x. That tells me in the f function to change any x that's to the right of the equal sign to a g of x, so that f composed with g of x is going to equal to 2 times g of x squared, changing that x to a g of x, minus 5 times g of x, changing that x to a g of x, minus 3. And now I'm going to change each of these g of x's to the right side of the g of x function, which is x minus 3. So this is going to give me f composed with g of x equals 2. And then I'm going to change this g of x to an x minus 3. So 2 times x minus 3 quantity squared. Minus 5. Change that g of x to an x minus 3. So 5 times x minus 3. And then minus 3. Now I need to be careful when I simplify this, and orders of operations want me to do the exponent first, so I'll do the exponent first. This video probably looks different than me solving the last problems because I made a mistake when I did this problem. So I'm trying to fix that mistake, and the first thing I'm going to do in the simplification is FOILing. First will be x times x, which is going to give me an x squared. Outers are going to be x times minus 3, which is a minus 3x. Inners are minus 3 times x, which is another minus 3x. And lasts are minus 3 times minus 3, which is a positive 9. So I'm going to simplify this and put it after the 2, but inside a parentheses as I go back to my work. So f composed with g of x equals to 2 times x minus 3 squared, but in place of the x minus 3 quantity squared, I'm going to write a simplified version of that by combining these two minus 3x's to a minus 6x. So I'll get 2 times x squared minus 6x plus 9, and I'll leave the rest unsimplified, but I could clear this parentheses on this line, but orders of operations technically say to do exponents first. So I have the exponents done. Now I'm going to clear the parentheses by distributing. First parentheses, when I go to clear it, I'm going to multiply 2 times x squared and get 2x squared. I'm going to multiply 2 times minus 6x and get minus 12x. 2 times plus 9 and get plus 18. And then the tricky part,
minus 5 times x, and minus 5 times x is going to be a minus 5x, and minus 5 times minus 3 to clear the second parentheses, you're going to get a plus 15 because the minus 5 times the minus 3 as I distribute, it's going to flip the sign to plus. And then I'm going to bring down the minus 3. I'm almost done. I just need to combine like terms, and if it factors, make a stab at factoring. The 2x squared is going to be part of my answer because there's not an x squared term to combine with it. The terms with the x to the first power, the minus 12x and the minus 5x, because the signs in front of the x's are the same, I add the numbers and keep the sign. So I'm going to add those and get a minus 17x. And then the constants, the plus 18, plus 15, and minus 13, when I do plus 18, plus 15, minus 3, that's going to be 30, because 18 plus 15 is 33, minus 3 is 30, and it comes out to a plus 30. So I think this is my answer to number 33. I should maybe make a stab at factoring this, because if it factors, it would be nice if I factored it. So I'm going to make an effort at factoring, but I don't think it factors. So I'm going to attempt to bottoms up factor 2x squared minus 17x plus 30. First step in bottoms up factoring is to multiply and rewrite. I'm going to multiply this 2 and that 30 and get x squared minus 17x plus 60, because 2 times 30 is 60. Now I'm going to factor this. My signs are minus and minus. My firsts are x and x, and my lasts have to multiply. Oh, wow. To 16, multiply to 60, hello, and add to 17. And 12 and 5 do that, because 12 times 5 equals 60, and 12 plus 5 equals 17. And guess that factors. I'll be darned. I didn't expect that to factor, but it did. Okay, so let me do my bottoms up factoring. So my lasts are going to be a minus 12 and a minus 5. Last step in my bottoms up factoring is a 3 in 1 step. I'm going to divide by 2, reduce in bottoms up. The first fraction reduces, so I'm going to get an x minus 6. The second fraction doesn't reduce. I bottoms up the 2 and get a 2x minus 5. I check that in my head really. Minus 12, minus 17. Yeah, that works. So that's actually going to be my final answer. So when I go to write my answer to problem 33, because this actually does factor, I should say f composed with g of x is x minus 6 times 2x minus 5. If you miss the factoring on a test, a lot of times I don't take points off. Worst case scenario, if you miss the bottoms up factoring, I'll take 1 point off. So that's 33. I'm going to do 34 and maybe 36 on the next page that I have, and then I'll make a part 2 to this video because it's getting to be crazy long already. So 34 is a lot like 33. It wants me to find g composed with f of x. So as I go to do problem 34, when I go to do g composed with f of x, I know that g composed with f of x is the same as g of f of x, and that tells me in the g function to change that x to an f of x. And because that x doesn't have an exponent, a coefficient, or a minus in front of it, when I change that x to an f of x, it doesn't really need to be in a parenthesis. So I'm just going to write f of x minus 3. And now I'm going to change the f of x to 2x squared minus 5x minus 3, because that's what that equals to. So this gives me g composed with f of x equals to 2x squared minus 5x minus 3 minus 3. I'm going to combine like terms, then attempt to factor. The like terms are the constants at the end. They're both negative, so I'm going to add them and keep them negative and get g composed with f of x equals to 2x squared minus 5x minus 6. And now I'm going to attempt to bottoms up factor that. This is likely going to be my answer, but if I try to factor 2x squared minus 5x minus 6, first thing I'm going to do is multiply and rewrite. I'm going to rewrite this as x squared minus 5x minus 12, multiplying the 2 and the 6. And then I attempt to factor this. The signs are going to be plus and minus. First are going to be x's, and my last have to multiply to 12 and subtract to 5. The factors of 12 are 1 and 12. Those subtract to be 11. Those aren't the factors that I need. 2 and 6 multiply to 12, subtract to be 4. They're not the factors that I need. And 3 and 4 multiply to 12, but they subtract to be 1. They're not the factors that I need. Because I can't find a lasts that multiply to 12 and subtract to 5. The x squared minus 5x minus 12 is prime. By default, the 2x squared minus 5x minus 6 is prime. So that doesn't factor. And I'm going to stop right here and say this is my answer to number 34. All right, last one before we make a part 2 to this video. We have 35 and 36. Let me just do your 35. 35 wants me to find g plus f of x, and that's easy. That's just g of x plus f of x. It's been about 3 months since I recorded this video, and I don't remember how picky I was about parentheses. Parentheses in this case really aren't going to be necessary, but they're never wrong. When you're changing from function notation to the right side of the function notation, you can put that a parentheses where the function symbol was. So I'm replacing the g of x and f of x symbols with parentheses, leaving the plus signs between them. In the first parentheses, I'm going to put 2x squared minus 5x minus 3 is what the g of x function is equal to. F of x, messed up here. In the first parentheses, I'm going to put x minus 3 because that's what the g of x function is equal to. In the second parentheses, I'm going to put 2x squared minus 5x minus 3 because that's what the f of x function is equal to. So I should have written g plus f of x equals to. Now I just need to clear the parentheses, combine like terms, and attempt to factor. The first and second parentheses can just be dropped without doing any changings because there isn't a negative or a multiplication in front of the parentheses or an exponent outside the parentheses. So the first parentheses as well as the second parentheses can just be dropped. I need to combine like terms and write this in a nice order. So I did 34, I'm doing 35 right now for what that's worth. The like terms that can be combined are the 1x and the minus 5x and the 2 minus 3's. When I go to write this, the first term I'm going to write is the highest exponent term, which is the 2x squared. The next term I'm going to write is going to be the x to the first power term. That's going to be what I get when I combine the x that's an implied 1x minus this 5x, and that 5x, and that's going to give me a minus 4x. The last terms I'm going to combine are the constants, the minus 3 and the minus 3. Those numbers are both negative, so I'm going to add the 3's and keep them negative and get minus 6. This is almost an answer, but it definitely factors a bit because there's a common factor of a 2. So on my next line, I'm going to factor out a 2. When I factor out a 2, I'm going to be left with x squared minus 2x minus 3, just by dividing all the numbers by 2, and this factors again. So I should probably factor this to have a completely factored answer. If you give me a correct answer that's not factored, you're probably going to lose a point on the test. So I'm going to go ahead and factor this. I don't need bottoms up because there's not a number in front of the x squared, so my first would be a couple of x's. My signs are plus and minus. My last need to multiply to 3 and subtract to negative 2. That's going to be 1 minus 3, because 1 times minus 3 is minus 3. 1 minus 3 is negative 2. This is going to be my answer to number 35. All right, so this is a good stopping point because we're already probably over an hour, and then we have a next kind of problems. They're real similar problems, and maybe they're a little bit different because there's numbers in the parentheses as opposed to letters. So this is a good place to break this into a second video.